What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. Today, we're gonna be doing these practice problems. So if you're studying alkenes, stay tuned. So our first problem, we have an alkene here with HCl. So what you need to decide is if this is Markovnikov or Anti-Markovnikov. And basically how we're gonna do it, we look at our alkene, we know that's nucleophilic because it has an extra pi bond. And inside the pi bond, we have an extra set of lone pairs. So the lone pairs are nucleophilic, and we want to travel to an area that feels more electrophilic. Now, why does our hydrogen feel electrophilic? Because our chloride is electronegative, and we have partial negative character pulling on the hydrogen, thus we're going to make the hydrogen feel more likely to be attacked because it's deficient in electrons. So what happens then is we push out the chloride. Here's a Cl minus. And then we have a decision to make. With our alkene, we have a single bond now. We don't have that double bond. Over here, we had one hydrogen. Over here, we had two. So we still have those same hydrogens. However, we're gaining a new hydrogen, right? This is going to be our green hydrogen. Now the question is, where does that hydrogen go? Is it going to go more in this region, which we'll call region A, or is it going to go in this region, which we're going to call region B? Well, based on our Markovnikov understanding, we're going to place the hydrogen here at letter B. Why? Because at letter A, that's going to form a more stable carbocation. We want to have a more stable carbocation instead of an unstable one, right? Because tertiary is more stable than secondary. Secondary is more stable than primary. So we're going to put a positive sign at the secondary carbon. We're going to put the new hydrogen there at letter B. And now we can have that chloride that was kicked out earlier can come back and go to the secondary carbocation. And that's what's going to allow for us to form the Markovnikov product, which is our chloride attached here. Now, the only time you'd get an anti-Markovnikov is if you have HBr and ROR, right? Or, right, HBr in H2O2 is the same thing as HOOH, which is the same thing as R2O2. Now, I won't do that mechanism today. That can be its own video. But knowing that this mechanism here without ROR is going to give you Markovnikov, versus if you have ROR specifically with HBr, then you're going to get the anti-Markovnikov answer. So here, you're going to get your Br in your anti-Markovnikov spot. Up here, this is your Markovnikov. And then the same mechanism applies here, right? We attach the H. We have to form a positive sign, put the positive sign in the more stable spot, then have your Br attack. There goes the Br. So both of these are Markovnikov, and then anti-Markovnikov with HBr and ROR. Now you can have Markovnikov and anti-Markovnikov of different things. So in the next video, we'll do Markovnikov, anti-Markovnikov of a OH alcohol functional group. But today we're mainly just focused on the halogenation portion with our HBr, HCl, HI. And we're specifically working with double bonds here. So in the next videos, we'll do a few more, but this is a good place to start if you're learning alkenes and if you're learning how to do reactions of the alkenes, right? So, check out other videos if you, want more practice with learning how to make an alkene. But right now, what we're going to be focusing on is doing a bunch of reactions of our alkenes. So stay tuned and we'll see you next time.